As I was talking about, it radically Splunk radically lessens the outages and so forth. And giving you example of one more use case in which I have identified in my current role. But just to give the commercial aspect of that, and as the examples talks about that, Vodafone has reduced their time to investigation by 70%, and escalations have been reduced by 90%. And so as another e-commerce portal saves huge amount of hugely with the help of the Splunk, and there has been a zero downtime in last 3 years, so to speak. So just to move forward, I would just describe some of the core components of Splunk just to get the ball rolling. We do have search head, which is a search tier, where the user go and search for something they were looking for. How that works, the search is sent to the indexing tier, where because this is the non-clustered distributed environment, so the data from the lower level, the collection tier, goes to indexes whichever is available, and when the search goes to those indexes, all the indexes receive the query and collect data and send it to the search head, and where the merges. So there is a like a negative or impact of the replication, because data is not replicated. All right. So I would come back to that later, but that is what indexers do. How indexes. This is the one job of indexer, but indexer also indexes the data. What that means, indexes is your repo for your data. Data could be coming from your collection tier. It could be coming from your from the forwarders, which could be your universal forwarder and heavy forwarder. The subtle difference between universal forwarder and heavy forwarder is that universal forwarder has the very small footprint to collect the data and push the data to the indexing tier, whereas heavy forwarder is a full-blown Splunk instance where most of its capabilities are disabled, and it just forwards the data. One can enable heavy forwarder to store the data as well, to index the data and send the data to the other systems. Like for example, you have another monitoring tool. For example, the one I'm talking about is LogArc or something, where your data is going for the enterprise security. It can go and so forth, or to a repo repository, S3 buckets and so forth. This was the traditional way of collecting the data, universal forwarder and heavy forwarder. The collection tier has grown, and now we have the HEC, which is your HTTP event collector. HTTP as a protocol is a very lightweight protocol, and you can set up a listener, HTTP listener, which can send data to directly to the indexer. But the best way to do that, to have your heavy forwarder be your HTTP listener, where the data get ingested from your syslog servers, and it can store it as well and push to the indexing tier. And apart from that, you have data from other inputs, could be a modular input and so forth. So that's the first three about the search tier, where you search, go for searching the data. Indexing tier, where the data is stored and helps in the search as well. Collection tier, where the data is collected and pushed to the indexing tier. Further, we have a management tier as well, where you have a deployment server. What deployment server does is actually replicate or like push the artifacts. Artifacts could be your apps to the search head, to the indexing tier, and to the correction tier. For example, you have set up like a source input from a server, from an application server. There is a location that you all set up in your inputs.conf. So that kind of configuration is you can set up in an app, and you can first set up the like a network layer, which is like enabling the ports 8089 and so forth, where you can see a particular client host, and once it is there, you can create the server class, which all does the gamut of works. So that is one of the role of deployment server. I won't go in detail what it does in the indexing, because the real magic for deployment server for the indexing tier is coming when we go to the next level. Moving forward, we have a license manager. What license manager tracks how much data have you used per day. And if you have, for example, when you are just starting and using Splunk, and you're just like in a free version, for example, so you have only bandwidth a limit of 500 megabytes. If you go overboard, license manager, Splunk license manager would raise alerts. Okay, mate, you can't do that, and stop for now. And that's how. So do you have any like a console where you can see your whole infrastructure, Splunk infrastructure? The answer is yes. You have a monitoring console, which actually shows you whole like a graphical view, or like a intuitive view, where you can see your index search tier as well, where you can see your indexing tier as well, how indexers are working, how buckets are working, and are they rolling up, and things like that. And you can also track your lower tier correction as well, like it tells you so how many forwarders are being set up, and so forth. Before going forward, any questions on this, please? Hello?
Yes, no from my side.
Okay.
Pranav, actually Splunk will work on the data size, or it work on some of the individual like IPs or the devices based, how it works?
You mean to say like
Like if I want to
I
purchase
didn't
a
get it.
Splunk now, I don't have a Splunk in my infrastructure, so I require to bring the Splunk into infrastructure. So the sizing of the Splunk will be how it will happen. It will be having on the size of the data of all the devices which I require to be monitored, or how it will be.
Okay, regarding the sizing, the Splunk takes the data in a raw format. Like whatever you ingest in Splunk, it goes to the like how that happens from your collection tier. It goes to the indexing tier, where all the parsing and happens at the indexing tier. And because it's a raw data, so it takes, okay, how much bandwidth of information has come, and so forth. Talking about you are sending network logs, if I understand that correctly, right?
Yeah, network logs and if required server logs, all the logs should be there in the Splunk, right, to get the some informative information from that all logs.
Yeah. So in terms of the licensing, how much bandwidth of the data you send, it's calculated per the size of the logs, and it passes through the licensing pipeline as well, where it is calculated, and it is stored in the indexing buckets. So when we talk of the buckets, you have to set up the indexer. You have to set up the index. So, for example, you are saying that checkpoint logs you are just monitoring the checkpoint log. So you set up a syslog server which collects the checkpoint logs probably on a TCP port or UDP port, and once it sends the data so like you have to have like a heavy forwarder over the syslog server what you have configured, and that will send to the indexing tier. Once it passes from the once the log lands to the indexing tier, then the passing and pipeline starts, where the data get passed for the line breaking, for the time stamps, and for the and adding the low level details like source and so forth, host and all that. And once that is all sorted out, it is connected in a bucket. By default, it goes into the hot bucket where the data is like is real data. What I mean, like all the searches happens from the hot bucket initially. It looks after that, and when the data get ages, because there is a time limit to retaining a log or event. Once that surpasses, it goes to the warm bucket, and once it also has a time limit as well, and then it goes to the cold bucket, and finally frozen, where it can be purged or can be saved for further. Sorry, did I somehow answer your question?
Yeah, it's fine. Just I want to know it like the licensing will work on how like the data sizing, or it is like an individual, how many devices do we have? So that was my question. Like
not on the number of devices, but on the size of the data.
Okay.
Yeah.
Then fine.
Hi Pranav, this is Ramandeep Singh. I have a quick question. I have been using Splunk from like almost an year now. However, I have recently came through this open source security platform known as Wazoo, which is basically just like a open source enterprise ready security monitoring solution. Like it basically provides all these like solutions that Splunk provides. So why do we still need these licenses basically? So if there are like open source solutions available, I'm just wondering why we need these licensed softwares. Like why do we need these licensed tools? Why do you recommend Splunk over other SIEM solutions?
Okay. So Raman, right?
Yes.
Yeah. Raman, I guess as you have told that you are using Splunk for an year, and also the other open source tool Vasu, was it?
Wazoo, yeah.
Wazoo. All right. So I am not sure how Wazoo looks like and how Wazoo its USP and things like how intuitive it is. But at the same time, enterprise security is a different ballgame altogether. Enterprise security out of the box, once you have the SIM compatible data like when the data get ingested from your security appliances, for example, firewall, AV, IDS, IPS, and switches and whatever, AD accounts and so forth. You send the SIM compliant data, right? And the benefits of using the SIM compliant data, for REST, SIM compliant means common information model that Splunk always over the premier apps, it asks that the data should be SIM compatible. There are the data models that are running behind the lines, which actually make sure that you get the benefits of the events, of the notable events, threats, what's happening in your infrastructure, to make the things very subtle for Splunk to identify that information, it always asks that the data to be SIM compliant, or you can make the data SIM compliant using the various factors. So let's not go overboard on that one. Why we use Splunk for enterprise security? So we use Splunk for enterprise security, or it's a preferred. I'm not boasting. I'm not selling Splunk at this juncture, but I would say the amount of time Splunk returns the benefits, or the benefits in terms of identifying the issues is much faster as compared to setting up another or using another tool that would do in the same time. I have had experience with ELK as well, and some of the audience, if they know around ELK, it's the Elastic Logstash Kibana. So there are three different components. What Splunk does in one way. So you have to go and set up each one of them. Like you have to know about the data in particular. You have to know the fields when setting up ELK, and you have to make them relational. How that, for example, when you're setting up the database, how the relational happens. So you have to set up each and every kind of a fields in the database, and make sure they are normalized and so forth. Not to that degree, but ELK is different. But when you start using Splunk, most of the gamut of configuration is being done automatically. For you, it has further to that, Splunk got free apps, like to my knowledge, it is like 20,000 or 10,000 plus apps, and still growing. That list is still growing from each and every vendor. Like for example, I was looking over the Who XML API kind of that was used for the for one of the security use case. So that app is also there. So just to give you an example, as we are growing further, Splunk goes much ahead of us. Splunk APIs, Splunk apps does help to do nitty-gritty stuff what would have taken a lot of time in terms of setting the other solution. So Raman, I'm not sure how far I am with answering your question.
No, I actually understand. You pretty well said. Mostly most important point where you mentioned ELK stack versus Splunk backend. Basically, I understand it basically uses indexers and all those heavy forwarders and universal forwarders that comes into play. I understand that network communication though, but I mean, Wazoo basically sits on ELK stack. You have to basically install Wazoo API on Kibana dashboard, and then on the backend you have a ELK stack and Logstash. But thank you. I actually got my answer. So cool.
Thanks, Raman. And it is interesting for me to know another product, Wazoo, and thanks for that information as well, Raman.
Sure.
All right. Okay. So, gents, let's go ahead. I guess I have. Let's take back to my present. I'll start from where I was. So, okay. Am I clear around what are the core components of Splunk? And let's go ahead. So, a very, very intuitive and very useful question, like why I should scale. I'm getting my data. Why I should think ahead. What's stopping me? Why I will spend my time in all this. So the answer is, for example, today you are ingesting 300 gigs of data. For that, a single search or indexer would still work. It will still give you the information, still give you the results. But at the same time, data grows exponentially. As I've said previously, data it's pervasive. Okay, it grows. It never stops, and as an organization which always looks for enhancing their footprint into the market and get the best of the best solutions to have them that would sustain them, at the same time help them to grow further. So taking that example, let's for example, 1 year back you are or today you are ingesting 300 gigs of data. Tomorrow or maybe 6 months down the line or 1 year down the line, data would grow. So you would need to handle the indexing. You will need to handle the searching, right? And the buckets would grow as well. At the same time, the second point is number of users. Um, as the organization grow, the number of users or number of concurrent users. Concurrent users means the users which are doing the search, or they could be safe searches that are running behind the lines. That would give you the information at a particular time, or sending you the alerts, or updating the dashboard. Dashboard is gamut of panels you have set up that would run searches behind the lines. So they will need computing power. They will need they will need the resources for that. There could be another use case that you want to expand, right? You want to scale. And there could be another use case where your searches are taking longer. There are various gamut of activities why the searches are taking longer. Be it at the indexing layer, the what you call the data is not correctly passed, line breaking is not adhered, then time stamping is not being captured correctly. So you have not set up your config files, for example, rightly, and so forth. So there could be 10 different things, but at the same time, when the user base grow, and when they are searching huge amount of when they are doing their searches on the huge amount of data for tiny result, like for example they are using stats to get the data conglomerated or get a summarized into a small speck of maybe percentage of information. So that search goes towards searching all those buckets, all those time at a longer time period. So there could be another use case. And for example, the business grow, and now they want to capture the security as well in their infrastructure. Maybe they are using some of the tools like a checkpoint or Palo Alto or Imperva, and for IDS, IPS, and they want to monitor the switches and so forth. So they need enterprise security. And for example, the business use case would be they want to use the ITSI. ITSI is information technology for service for service level. So thereby you can set up various dashboards around that, which in ITSI provide on its own. Like that's the USP of ITSI. Or you need to have the use case where you need to capture the notable events from internal threats from your either rogue employee or your rogue machine could be doing something. So you need to capture that. That's another use case. So the other some of the use cases that would intrigue, or that would call you to scale your application, so to speak. Any questions on this, please? Before I move ahead. Okay. Sorry. Okay, I go ahead.
Hi.
Hi, sorry, who's that? Okay. Um, this another slide would talks about like what are the major criteria for you to think about how it to be scaled, and one more thing that I would like to mention, what are the key benefits for me to scale. I'm looking at the performance of my infrastructure, performance of how I could better utilize my resources, right? And I want to reduce the complexity in my infrastructure. So there could be complexity as the benefits. I want my infrastructure to be as efficient as my business is. So there is a benefit of efficiency. Then reduce the cost. Given the example of AWS, uh, today the organization doesn't need to have the whole data center and invest in taking the real estate, setting it up, and monitor day and night, and set up and invest into a resource or resources who will do that. So thereby organization would save on that cost. Agility, they want to be quick, they want to be up in the market, they want to stay ahead of their competition. So agility is one of the very much key benefits. Maintenance, they want to reduce the maintenance cost in setting up the scalability. Like for example, in the early distributed environment, where we have seen when where we don't have replication factor. Replication means where the data is not replicated among the indexers, and if one of the indexers goes down, then the resources are required to make it identify why it stopped, how it can be monitored that it should not stop, and things like that. So the maintenance comes at that point. So if you have a clustered environment, you have the replication across the indexes. So there you go the maintenance. Scalable. Given the amount of data which is exponentially growing from your infrastructure, that involves your data center, sorry, that involves your server, that involves your applications, that involves your network, that involves your like individual machines as well. Data is growing, so the organization would like to be stay ahead and maintain that scalability. And the verification comes for the key stakeholders. Key stakeholders want to make sure, they want to be assured that they have invested the time, money, expenses, and the resources on something that would give them returns. There has to be a total cost of ownership on that one. So at that time they want to verify. Okay, I have invested 100,000 on this part of the sort of taking a product. I want to get returns. What are my returns? I'm saving on the minimum time it takes to investigate, minimum time to get it up and running, minimum time to have any outages, for example. So if there be any outages, I have my system scalable. So there will be some things component that will take care of itself. Or in that regard, so uh, I would again stress the benefits of Splunk is much ahead of what it talks about, and what it is, the product as a whole. And thereby, I would still say use it, find the benefits, and you won't go wrong to identify a nice product, so to speak. Any questions on this before I go ahead, please? Okay, I will understand.
Hello.
Hello, sorry.
Hi, Pranav. Sorry to interrupt. Can you go to the previous slide once, please? Yes. First of all, I'm pretty new to this thing, so can you, in a very brief, in a minute, can you just walk through where the data goes from which here to which here, and then the final result? I know this is a very basic question, but I'm pretty new to this.
That's fine. I'm hardly able to hear you. Sorry, I don't get your name. Can you please tell your name and repeat your question again, please?
My name is Tejas.
Okay. Hi,
And
Tejas.
yes, I'm pretty new to Splunk, and probably this first webinar for me. So can you, very brief, in a minute, can you just walk through through the tiers of where data comes from, where it goes, and how the processing is done at this tier and then presented at another one. So just a walkthrough in a few seconds, probably that will be helpful.
Okay. So let me bring you this slide, which shows you the core components. And let's go from the lower level where the data comes in Splunk. So, for example, today you have a Java application running, and you would like to collect the data, and it's an kind of like your web application where you have access clouds and you want to collect that. So, okay, if you go ahead and setting this up, you would set up universal forwarder on the host Apache server, which would collect data. All right. Then the data goes to the indexing tier, where the data get where the data get passed. What I mean, there is a passing pipeline where it looks after the event breaking. It looks after the various other things that I've already covered. And once the data gets stored into the buckets, once it gets stored, the data is the data is ready to be searched. So you can you or someone in your team can go and search the data. And apart from this, there are other management layer as well, management tier as well, which looks after to make sure all the search tier, indexing tier, collection tier works in RIM. I would suggest for you to go, and there is a free course for Splunk that you can take from Splunk.com. You need to register yourself and go and understand various components of Splunk and how it works. So it would be useful for you, Tejas.
Thank you so much, Pranav. It was helpful. Thank you.
All right, thanks, Tejas. Let's go ahead where we stopped and moving ahead to the indexing cluster. So now we have understood that data is exponentially growing from 300 gigs to 600 gigs. My user base is not that much growing, so I've kept my search tier to be a single search head, but I have made sure my indexing tier is clustered. What that means, there is another cousin over here which is called CM, which is called the cluster master, right? Or indexer cluster master. What that guy does is to make sure that in these index tier is able to replicate the data. That would make sure that it's able to replicate the data. It's able to the artifacts for the indexes, and if there be any roll up things happen, cluster master takes that ownership. So, for example, you are running a Splunk shop where you have identified, okay, let me add the new data source, and for me, for that to be done, I would need another indexer. Sorry, in an index, which is your repo for that new data source. So how would you do that? It's best to be done via the apps. So you would set up in index.conf app where there is only one index.conf to be updated, that you will go and add a new index and update that app via deployment server to the cluster master. Cluster master, when it gets that app, its main task was to make sure that index get added to the buckets. How that will done? It will do a rolling restart. So that is another uh, another what you call another use of having a cluster master. And it also takes care of the replication factor as well, like the data to be replicated. What I meant by the replication factor, it will make sure the data is available, all right, and data is available, data is able to recover in terms of when one of there are three there are three indexes over here. Come a day when one of the indexes go down, what will happen? Will I lose my information? Will I able to not search the information? The answer is no, because there are two things that needs to be set up at the server level, which is at the when you set up the cluster master, you need to make sure two things are very important, which are replication factor and the search factor. What replication factor means, that data is replicated across my indexer. We have three indexes, so data is replicated across all three of indexes. So if one of them goes down, my data is always there. And there is another thing, which is a search factor. So what search factor means, that come a day when a search head sends me a query, and bear in mind one of the indexes is not there with me. So I am only with my two indexes and one search head. So search head is sending you the query and making sure the search factor is defined as 2. What that means, in each of the given the two search given the two indexes, the data is able to search on them. This is very important concept. I would like to go through that again for the people. Uh, I have introduced one more very important concept of indexing clustering. Indexing clustering comes where the data get replicated, and there is a cluster master that makes sure that the data gets replicated across the indexers, indexer tier, and it would make sure the data is available, the data is fidelity. What that means, that whatever data is coming from your collection tier is uh, saved in that entirety, right? So there has to be no data loss, for example. Then as I said, data is able to recover. For example, if index one of the indexes out of 3 gets down, then you still have still be able to search the data. Come a day, 2 of the indexes goes down. Are you able to see the results? Yes, but there could be a lag, and there could be a lag. Your historical data would still be there, but with the new data, there could be some lag of the information, or it would say that data is not available and things like that. I have seen that. That's why the experience comes from that. So I hope I've tried to make it clear. But for anyone, if they have any questions, I would much appreciate to hear. Sorry, I guess I have gone too fast, or everyone got understood what I am talking about?
I think you're good, Pranav.
Okay, thank you. So let's move ahead. And There are some of the best practices of setting up the indexer cluster. There is a concept of enable parallel pipelines on the servers. For the servers, let's say there are too much of heavy searches that going ahead. Parallel pipeline adds another level of benefit to make sure the data okay, when the data is sent from the collection tier to the indexing tier, right? It goes through a single pipeline, right? And which does all the gamut of making sure the data get passed correctly and making sure there is line breaking timestamp and so forth. There is a time zoning added to that and so forth. But once you have the parallel pipelines, it would be saying like we see in a distributed computing, like you break the job into small chunks, and they would be processed individually. And once they give the results, they would be merged and give you the output. Here I would also say Splunk runs on the MapReduce. For people who are new, it would be good for them to understand how the MapReduce works. If I give it a very small, basic, a quick rundown, in MapReduce, it is a two phases, like it's a map and a reduce. What does that mean? Let's say there is a data A, and there is from data A, and there is another data B, which is sending different information. So, sorry, I'm losing my breath. So what happens on your infrastructure? The data A goes to one host, and data B goes to another host, which is sending similar data if not different. And it just on a statistical point, it just breaks the data. And when the data got broken, it is into the individual components and come at the reduced phase where the data get merged. I know I may not be in my entirety across MapReduce, but it is a very, very important concept for someone to understand that. Like, for example, Hadoop works on the similar lines as well, but in a different channel. So it would be really good to understand that one. And for the parallelization, there's one more caveat or one more requirement, is that it would require excess CPUs because data is broken and another pipeline is running. So, for example, you have 12 CPU core. You would need another additional core 12 CPU to run that pipeline. So, because that pipeline is doubling the work on the processes, doubling on the IOPS, which are very much prevalent, very much required for the Splunk, and hence you have to be very good in your resources, have ample of resources, so to speak, to do that. That is the only caveat. But once you enable that, nothing will stop. But at the same time, make sure that there is ample resources, otherwise it would have the negative impact on the search and indexing performance for sure. Another part of that, you can enable the batch mode search parallelization. There is, I guess it's in the server.conf, which provides those parameters to be enabled in the clustering stanza or something, where you say, okay, enable the batch processing mode and so forth. So once you do that, there would be additional search that could complete in the panel and would give you the results quickly. And another, like in my experience, and currently most of the infrastructure is set up on SSDs, and which are very high and results driven disks, very quick and so forth. So hot and warm buckets and summaries are to be set up on SSDs to be sure to use the entire benefits of index clustering. It further goes to a level that that your search tier and indexing tier should be in the same network, but given in my experience, I've seen that like for example, I'm using the Splunk Cloud for one of the client, and all the information from their heavy forwarder goes to the indexing tier, which is hosted into the Splunk Cloud, and thereby it goes like terabytes of data get ingested in Splunk Cloud, and you would see it within, I guess, how much second was it? Uh, point 0.5 or something seconds. It gave the correlation result on the search, and it gives the output. So that's the beauty of having to keep the latency and network latency low, and having the indexing and the search tier in a one sort of infrastructure or the network layer. In the index replication would always you can index replication is not something that happens automatically. You need to enable index replication so that you can take the more benefits of indexing tier. Its USP is that the data gets replicated. So does indexing replication needs to be enabled. And one of the best practices, like I have never seen where indexing nodes have their UI enabled, so it's better to shut them off from the configs and so forth. And to make sure that is very prevalent and very important for the new users to make sure that take a sample of log data and set up their apps so that the line breaking is taken care of, timestamp is extracted correctly, right time zone is to be applied, and source and that information is there. So that's a bare minimum. I would say I can run couple of examples in my experiences where one of the big banks were getting their heavy getting their data pipeline quite heavy, and some of the data ingested were poorly indexed, I would say, or poorly coming from the collection tier, where the apps were not apps were just sending the data, and it was not correctly doing the setting up the right line breaking. You can set that in your conf files at the start of it, and can relate the timestamp and so forth, and identify that at the start when the data gets ingested, rather than doing it at a later stage. So that would cause the search to take more time, more CPUs, and more IOPS to give you the results back at the same time. And so does it's prevalent that we set up the inputs.com that would have the source identified, and set up the index where the data should go, which bucket, and set up your source types that would really identify, okay, it's coming from application, coming from network, and so forth, and a source that would be a big that would be initially a stanza where you need to set up. And on top of that, you always have monitoring console that would give you the full view of your Splunk environment, and where you can go and deep dive into your indexing tier, how indexing performance, would there be any skipped searches, how your search heads are behaving, and what are the and how many are the what you call the forwarding layer or collection tier is set up, and can give you that information, and also in the license usage, so to speak, you can set up alerts and because I can relate something happened over this week in one of my someone in client side have enabled the source. Was it? Hang on a sec. It was it was the CMDB ServiceNow CMDB that was triggered, and it was sending from 6 gigs to 14 gigs. So the data just got exponentially grown, and that has caused the Splunk licenses. And thank God I've set up the alerts and all that, so able to identify what has happened, but so forth and so on. Given all this information, do you have any questions at this stage, please?
Pranav, hi, this is Tejas here.
Hi, Tejas.
Pranav, since we have been talking about the advantages of this tool and the way it works, are there limitations as well, or since you have been working it since a long time, so have you been facing any challenges which are maybe difficult to deal with, or any limitations, basically practical limitations?
Very good question, Tejas. And yes, needless to say, majorly identifiable challenges, not in terms of you using Splunk, but how the configuration being done or incorrectly. Like in this journey, I have learned how to do regex a little bit. How to use the config files and basically identify the data at start. I would say at the search tier level, you can a bit of it. And having set up the indexing layer is one of the and there is another part of that is a search head clustering, which also adds more complexity slash scalability to utilize Splunk. And in terms of identifying, once you have the good grounding, I would say how the various components of Splunk work. It is all about making sure that you're focused towards how data is captured, making sure the buckets are rolled up, buckets are set up correctly, making sure. One of the things I would say it has happened that very pertaining when I was working for a credit firm. It so happened that some amount of data just got lost. It is because at the indexing tier you need to set up the time how your information is get rolled up to the next level, right? And given the data grown exponentially and the timeline setup for that particular instance for that particular bucket was very small, and identified that the bucket just got purged at that time. Yes, at the forefront, I would say it was the data lost, but at the same time, because data was backed up on the S3 instances, the whole bucket got replicated when it goes from the hot, warm, cold to frozen. At the frozen time, you can replicate the bucket, or you can save the bucket to the different source location, or to a storage location. Sorry. So thereby you can have the data, and once you do the re-indexing, not you are doing the reindexing, but you are using the existing data because the data is in TSIDX format. That's once the data get once the data get stored from the indexing tier, it is saved in the TSIDX format. You can go and take a backup of that, so that in terms of any failures and all that. So that was one of the thing challenging atmosphere 3 years down the line. 3 years back it has happened. So I was at that time living the Splunk journey, and was learning from experiences and so forth. But it was really an experience I won't forget. So yeah, make sure you understand Splunk components correctly. Make sure the configuration files are set up in line with the documentation and so forth. And one more thing I would say. In November 2018, Splunk and Splunk engineers released a Splunk Validated Architecture (SVA). So, and some of the information or some of the learnings that I have put down in this slide, and what I have learned a lot from SVA is something that I would spread this word to everyone who is living the dream of using Splunk, and it would be useful for the new as well as the old Splunk users to see how the data can be scaled up, how the infrastructure could be scaled up, see what are the things that needs to be adhered to, and identify the topology and go from there. So I would say have a read through the I guess Stephen was one of the gentlemen who written, or was one of the gentlemen who was part of that. But yeah, go and have a read through Splunk Validated Architecture. It would be really good learning, and would be impactful in your journey, I would say. Sorry, Tejas, I have gone overboard and just blabbering myself and things like that. So have I answered your, or somehow you got some gist around that?
Yeah, it did, Pranav. In fact, you you shared the experience as well. Thank you so much for that.
Thanks, Tejas. Thank you. Okay, moving ahead. This is the small setup I did using Dockerized environment. So you can see the peer name were not set up correctly. You can change the peer names in the host information files. There's a specific file for that server, or I forgot. I don't remember as of now. But this is how I set up. It would take me, I guess, 3 to 4 hours to just set this up. And this is how the actual Splunk cluster node looks like. As you can see, there are 3 nodes which are searchable, and here I have make sure. Hope I wish I could show you the edit and tell you where the replication fetter and search fetter are set up. You can do from the cluster master web GUI, or you can do from the clustering stanza in the server.conf, and you can set up. This is your replication fetter. This is your search fetter. Also set up your symmetry key as well. And there are other things that index discovery as well, which is very useful. How index discovery, sorry, I'm speaking myself, but how index discovery works, you don't need to just give the URL for the cluster master on 8089, which is the management port, and when you are scaling up your indexing tier, then you don't have to put the host name or /IP addresses into the config file. The indexer discovery will do that automatically for you, and the bucket gets replicated across your new tier, new indexing tier node. So that's a useful to save it. and the useful configuration that I would suggest for you to try and see if you have not. All right, next go ahead. Well, finally, we have come to a summary where I would just say identify the requirements and select the right topology. And indexing cluster gives you the horizontal scaling and not vertical. Vertical doesn't make any sense. You can just add more resources, but you would end up more damage than useful to your infrastructure. Go with the horizontal scaling. And what is the use of Splunk Master? That I would just brief you. It takes an replication activities between the indexing tier, so that the nodes and make sure the data get replicated. And it also manages the configuration of the peer nodes. Just I give you an example that new index is added to be added into the in your infrastructure. For example, cluster master will make sure that information goes and goes into the each and every indexing tier node, so to speak, and that is the duty of and the rolling restart happens by cluster master to the indexing tier. So it let's, for example, you have three nodes in the indexing tier. One, the rolling restart happen on one, then its hash get updated, then on the next one, and then on the next one. It's a funny gamut function when you have any node outage or something like that. It would make sure the primary bucket copies get is available on one of the peer node, one of the remaining two peer nodes. So the primary buckets are the main facets, and it takes very like a very important role when returning results to the search head. And for the peer nodes, it not only indexes the data, but also indexes the data by the peer node. So it does two jobs at the same time, and it supports the replication factor among the peer nodes. And the search head runs the search across the peer nodes and manages the searches across the indexing tier as well. So, gents, this is all about. And if you have any questions, I'm happy to hear. And thanks for everyone to be on the call at this afternoon. I know it's a Saturday, but thank you so much. And if you have any questions or something, I'm here and be able to answer that. And you can reach me on my email as well. And if I be able to help anyone, happy to help and see if I could make anyone's journey much more